can imagine this scenario where some rando walks up, gets someone's ID card, and just allows himself into a building. We need to prevent this problem, and that's why Hillary and I, Dennis, we're going to be here talking about the solution using facial ID technology to have facility access. So what's the problem? Well, the problem is I still have his ID in my hand. The problem is we're still using plastic ID cards for facility access. Most companies are. And the thing about these is that they can be lost, they can be stolen, as we just saw, forgotten, a million things can happen. And this is really bad because the employee himself or herself loses precious time, already has to go back home, get it, right? Has to find it. But not only that, the company's security is at risk now because somebody can just walk in and use that ID. In fact, that's why banks and financial institutions are going in using digital wallets now, right? With Discover, you can just freeze your account and you'll be fine. Right, so the point is, we're going to be using facial recognition for the facility access. It's the same idea. Right, so let's take a look. So here's a couple of use cases. So let's take, for example, a bank. Right, anybody can walk into the bank, but we don't want anybody to walk into the vault. Right, so there needs to be some extra security in some of these restricted areas. Another example is maybe a laboratory, right, a microbiology laboratory. We don't want anyone walking into the secure area, right? And so how can we use facial technology to kind of alleviate this problem? Well, we already see facial recognition kind of on the rise, right? We see that with some of the previous renditions, like Apple's FaceID. Apple pretty much just takes a map of your face and you're able to authenticate yourself into your iPhone. Another example is with airports. Some airports are able to just allow you through the checkpoint just because they have your face. So what we're thinking of doing is just taking these ideas and kind of putting into facility access. And without further ado, we can talk a little bit more about how the system works as a whole.
All right, thank you. So talking about how the system works, we are a 15-person team startup, which is trying to implement these as contractors for certain companies. So a client comes to us and asks for a contract to be able to implement such a system. Maybe it's a bank or maybe it's another facility. But this is an idea of how the whole system in general will work. So we decided to divide it into two phases, actually. The first phase is data acquisition. Because we depend on much on image data from people, we need to gather up that data and be able to perform some processing on that data, get facial characteristics that distinguish each person, and then be able to store it in a database. And we store those encodings as a map of maybe just one encoding to the person. The second phase is the authentication part, where now what we do is we feed in a live image to maybe a machine learning model, which is existing somewhere else. And then that machine learning model is supposed to reconstruct again the same facial features that it already had extracted in the beginning. At the same time, it attempts to reproduce the encoding, and we have a 1:1 lookup in the database whether that encoding exists. If that encoding exists, then that means that person is authenticated or that person is part of the system.
You said the machine learning model's reconstructing the features.
Right.
Why isn't it just sort of saying it is John or it's not John?
Well, so what's happening is that what we want to do actually is to be able to utilize that model. It's a pre-trained model. So what happens is that if you give it data, it doesn't have any authentication. We're using Sky Biometrics API call, so it doesn't necessarily have authentication. So it has to map out those characteristics for us, and we construct the authentication pipeline. But we'll talk about it more later. So now that we have this, we want to break down each system and what happens at each level. So the pre-trained API model that I was talking about comes from Sky Biometry Face Recognition API. This is a startup in Lithuania. It's pretty credible. It's one of the leading startups in terms of facial recognition. And what they're able to do is when you feed in an image, various images of the same person, different angles, different face lightings, they're able to reconstruct a specific encoding, which is primarily distinguished from person to person. That's what we're aiming for. And then for the server, what we're doing is we're relying on Amazon Web Services. This is just it's basically EC2 instances, which is just supercomputers that you can run on the cloud. Basically, the reason why we are doing that is because you're able to adjust the processing power of the computer or whatever you're trying to configure. And this helps because most of our code is running on the server to authenticate at the same time to talk to a pre-trained model via an API call. And we're also going to be using databases, also provided by Amazon Web Services, primarily DynamoDB, to store all that information as well. And initially, S3 buckets from Amazon Web Services, just to store all the image data that we collect from people. You have a question?
How big are the how big are the encodings? Like, will it take up as much like file size as like the images itself, or is it small?
Oh, these are just 64 bits probably, and that's enough to have a large population. Yeah. So now we're gonna go a little bit into the system breakdown bit by bit.
And that would be log 2, by the way, to do it. So it's much fewer than the file size itself. So we're going to talk about how the system can authenticate the user. If an employee walks in, what's going to happen is the camera is going to take a picture of them, view them, and then send that data, the person's face, to the server. Now, the server is going to do two things, and Hal was just wondering, why doesn't the model actually just say, this is John? Well, this is actually for privacy reasons. We ourselves want to keep the fact that this is John. We're just sending the face there and say, all right, just do a binary encoding. So the idea is the server has the picture of the person, sends the face to the model via API call. The model turns it into a binary encoding, so of ones and zeros, sends it back to the server. Now the server has these ones and zeros, sends that data to the database that we have that is under our lock and key, and the database is going to be the one who authenticates. It's going to say, hey, this person, we recognize and trust this person, let him in, her in. Or it'll say, no, we don't know this person, lock the doors, right?
If I have the encodings for all the employees in the company, the encodings, right, can I reconstruct pretty much the faces of the employees in that company?
I think we would have to kind of almost reverse engineer the model, and that's something we didn't explore entirely.
Yeah, so Sky Biometrics does not offer that service to be able to reconstruct images back from that distinguished.
Well, the question is, can attackers offer that service?
Oh, so
Sky is not going to do that. The question is, are attackers who get the database going to do that?
So it's very hard in the first place to get to a database. So you'd have to attack in the middleman attacks.
Standard, hey, our databases are secure.
Okay.
Yeah. And
Famous last words.
and we'll get more into security a little later as well. But basically, we are keeping it under very good lock and key. But we can talk about evaluation now. So in terms of our machine learning evaluation, using Sky Biometrics, we found that it's about 98% accurate, along with about a 3-second latency in terms of the travel times, which we'll get to in a second. But this stuff we found on the Sky Biometrics reference website. Another thing to keep in note is that the more we do this with more clients, the better this technology gets, right? And the better we get at being able to serve this to others. So the bottom line is this gets iteratively better.
Can I wear glasses?
Yes, you can.
Yes.
Can I take them off?
Yes, you can.
Sure.
So I need 2 pictures or 1 picture?
You need
Or
multiple
Or is
pictures.
the encoding good enough that it's insensitive?
It's kind of the same idea as Apple ID. So if you have Apple ID, you're able to get into your phone if you just have sunglasses. If you're
Right,
wearing,
exactly.
yeah, exactly. Cool. And now we're just going to talk about the round trip time here.
So in terms of evaluating the whole system in terms of performance, right from the time you have an image to the time you get a confirmation authentication, we want to first have to estimate how long that takes. But we do that by using the internet facilities or the internet links probably. And the reason why we do that is because the only thing that's in lag, or the only thing that's the bottleneck, is how fast our model computes an image. But also the internet speed matters. So if you're sending an image to a server, how long that image takes to get to the server actually matters. And how long that server computes a lookup actually also matters. So you add that all up, you're able to get a total round trip time to be able to get from an image to confirmation. So we're just gonna grab, these are the top 2, or I can say internet companies maybe in the country. And we're just gonna grab the download speeds and the latency, which are just the upper bounds of the bandwidth. And what we're going to look at is the actual plan. Is that when you have an internet link, which can be able to handle 100 megabits per second to 1,000 megabits per second at 50 milliseconds latency, it takes 1 bit of data, 50 milliseconds to travel. But if that bit of data exists in the latency, you're able to use the channel to travel 50 milliseconds to the server. And then from the server, because we're using the same platform, we estimate an upper bound of about 200 milliseconds for you to check what's in the server and then get a confirmation again. And then from the server down to the system to actually authenticate or to actually open a vault or open a door, we estimate again the 50 milliseconds for that command to get to an embedded system, mechanical system. So suppose you have an image of from 1 to 100 megabytes, because we're using high resolution camera, you expect that from an image. Because it fits inside the bandwidth channel from 100 megabits per second to 1,000 megabits per second, it's able to ship to 50 milliseconds to the server and then get a confirmation back and then back again. So doing this 2 times back and forth gives you 100 milliseconds. Doing this 2 times back and forth gives you 200 milliseconds.
So, just so I'm following, you're sending the actual image to the server,
Right.
and you're telling me that AWS is going to keep that secure.
Yes.
That's right, yeah, using S3. S3 is very trusted. A lot of people use it,
Okay.
including MIT.
Yeah, you're,
So because the model, when you make an API call to the model, this whole computation takes about 500 milliseconds to 3 seconds, but we only care about the upper bound. So in total, you have about 3.5 milliseconds till you get your confirmation. Now you may ask, okay, what happens when the image size is greater than the upper bound that we just said? Well, you batch the data up. And batching the data up involves you maximizing the latency and the bandwidth. So instead of having like a single channel, you're actually having like a cylindrical shape in some sense. If you can imagine this as a pipe.
Wait, so is that like breaking up the image and sending them separately, or like,
Not breaking up the image and sending them separately, but if you have, yeah, you're right, in that if you have an image which is 150 megabits, you break it up like into 150, and then 100 goes and 50 more goes. That's the essence of batching things up. Yeah.
So what about pictures with compression? Like, does the model handle those well? Especially like with the high resolution camera,
Right.
if it's a lot of space for one picture, like are they going to be compressed, or are you planning about, like, are you thinking about compressing the images before sending them?
So we're not planning on compressing the images before sending them, because what we're doing actually is that, because we're planning that batching almost takes up the same time, and we're able to maximize the channel maybe up to 50 times, it means that we can grab image data which is very huge. But in any case, that the data that we want to find in an image is so large that we can't perform anything, or it takes a long time to get to the server. That's when we can think about compression. But so far we have not been able to, we haven't had any problems with that, because what we are using are oak cameras, and these have machine vision algorithms, as well as their best offer the data that we need within this range.
Wait, so what the server's looking at in the database is looking for a faces encoding?
Yes.
Does the encoding always exactly match? Do you have to do like some kind of range query?
So yeah, we should expect it to exactly match.
Each face is unique, that's why they match.
But like, what if someone's face has gotten fatter because they've gained 10 pounds?
So we plan to get samples almost now and then every time to be able to adjust for that. So it's like in a timeline, in a few, like this year, next year, or next month. So it's a periodic adjustment of the database.
Okay.
good.
So now let's talk about the timeline it takes for us to execute among a 15-person team. So the first phase is just to set up everything. We might want to get the data from all the people, depending on the client size, the company size. It might take us about 1 to 2 weeks to be able to do that. Because what we are doing is that we are able to take pictures of different people at the same time under different conditions, different lighting, different angles. So that's a lot of time to be able to do that, and we're splitting it, assigning it to 5 people in the company. And then what we now do is somewhat to set up all our databases or data storages in S3 and also on DynamoDB, and to store that data and to set up everything, giving it to 2 people usually takes about a week. And then now we need to set up the AWS server or the EC2 instance. For 1 person, it takes also a week. And then now we need to design different API calls to send the image to the server, and then for the server to scour biometrics as well. And now we move to the second phase.
Right. So in phase 2, we're going to set up all the pipelines for authentication and the API calls with the server. So we designed the API in the previous phase, but here we're going to actually configure them and make sure that's able to be a good pipeline here. And we're also going to set up the database so we can have the authentication working. This is going to take about 5 people, and it's going to go from the middle of June about to the end of July. We have a little bit of wiggle room here, which takes us to phase 3, which is going to be optimization. And this is where we can use our compression, or we can find out better ways we can optimize the model. But essentially, we're going to set up the camera here. And once we do that, we're going to test the sending images to the server and setting up the authentication. And it's going to have a total of 9 people and take us until the end of September. So let's talk about a little bit of a security and privacy trade-off. So we kind of understand that you're the client. The client is going to give us a little bit of their privacy in exchange for some more security, right? And
The client is the company that is installing.
That's right, that's correct. And the thing is, we can guarantee that we're doing everything we can to keep the client's data safe, right? So the first thing is, of course, having a very bulletproof non-disclosure agreement here with all of our employees with a heavy penalty for crossing that. And the other thing is, we're not going to be selling any data. Yeah, what's up?
So what would the non-disclosure agreement be?
So in the non-disclosure agreement, we don't let employees publicize our dealings with our clients, that is the names of our clients, whether we're talking with Google or other company. All intellectual property belongs to the company and does not belong to the employee. So once they build something for us, we take it for the company. They're not able to say credit themselves to that. So those kind of ranges of securing all intellectual property to us are the non-disclosure agreements that we sign, and to keep anybody's client's names out of our employees' mouth as they collaborate outside, also maybe on their resumes as well.
So it's just making sure that people don't know that your clients are.
Right, yes, and primarily also into keeping intellectual property.
And remember, that requires that your clients that you're trying to do business with trust you.
Yes.
Right.
Because what happens when your startup goes bankrupt and you sell your stuff? They have no protection on that data at all.
Right. Well, we're hoping not to go bankrupt.
Well, everyone's hoping not to go bankrupt, but I'm saying if I'm the client, I say, what are my risks
Right.
in turning over all this information to some startup?
Yes.
Right? And you got to have a good answer to that.
Right. Well, that's a good point, Hal, and we'll continue to kind of go through the legal ramifications. But I mean, of course, like I said, we're trying to make sure that everybody's data is secure. We're not selling in or anything like that. And another thing that we can touch on is security, right? In terms of how we keep the data secure, we're going to use the AWS security protocol. So the idea here is public keys, private keys. Only Amazon has the private key along with us. And the other thing is in terms of Sky Biometrics, because after all, we are using their facial recognition model. We found that we actually chose this company. There's a whole bunch of companies. We chose this company because their ethics model kind of aligns with ours, and we kind of resonate with them in terms of data. And
Question.
Yep.
Oh, so I guess I had a security concern, because you
Yeah.
said one of your examples was a bank vault.
Right.
How good is Sky Biometrics at detecting whether I'm using an image of someone's face, because Apple uses projected infrared
Right.
to create 3D models? How good is Sky Biometrics at that?
So Sky Biometrics what it only does is take an image of a person, but we're planning that if you are standing in front of a camera, there's already a monitoring system that is checking whether that's a real person or not. So Sky Biometrics is able to distinguish that on itself in computer vision. But I understand that putting an image in front of a camera could act as a camera in itself, but we're also planning to have some human factors there to keep on checking whether a person is actually monitoring is in front of the camera. But yeah.
Cool. And we'll just wrap up here with the summary.
So what we're trying to do is to secure facility access using facial recognition technology. And the reason is that what we're doing here can be bettered by machine learning models, because they're able to distinguish between person to person using different facial characteristics and features. And in total, we just want you to support us in this vision. Thank you.
Thank you. Oh, you want to go first?